All right. This is section 3.1, example 1. As a reminder, section 3.1 is about tangent lines. And what we previously learned is the definition of the slope of a curve at a single point. So let's write that down as a reference before we try the example. The limit, I better write slower, as h approaches 0 of f of x 0 plus h minus f of x 0 all divided by h is our slope of a tangent line. Okay, so our first example is find the slope to 1 over x. So our function is y equals 1 over x, and we want to do it at the point x equals a. Okay, so in this case, what we're saying is that our x sub 0 is a. And the y value at that point, of course, would be f of a, which in this case would be 1 divided by a. Okay, so the function is 1 over x. Therefore, when you plug in x equals a, you end up with 1 over a. So what we're going to do is we're going to use this information with the slope of the tangent line definition above and see if we can come up with the answer. So we'll call this m for now, since we're all used to calling slopes m. So we have the limit as h approaches 0 of f of x 0 plus h. Our x sub 0 in this problem is a. So we'll call this, sorry, a little bit of a delay, a plus h minus f of a all divided by h. Okay, so we already know what f of a is because we wrote it down over here. F of a is 1 divided by a. So how do we figure out what f of a plus h is? Well, we do the exact same thing. We go and look back at our function, which is 1 over x, and anywhere we see an x, we're going to replace it with a plus h. So this limit can be rewritten sorry, there's a big old delay on my writing for some reason. Let me try that again. Limit as h approaches 0 So now, instead of f of a plus h, we can write 1 divided by a plus h. Because everywhere there's an x in our original equation, we're replacing it with a plus h. And then minus f of a is 1 divided by a, all divided by h. Okay? So now we've turned the generic formula that we have for slope of a tangent line into a formula specific to the function 1 over x at x equals a. So now the goal is to simply, or maybe not so simply, use algebra to manipulate this into something nicer, prettier, reduce it, simplify it, however you want to talk about it. So in order to do that, we know we're eventually going to have to apply the limit. And right now, if we apply the limit, we would be dividing by 0, which of course is not allowed. So we've got to manipulate this somehow to where we aren't dividing by 0 or dividing by h all by itself. So the first step I would say is looking at the numerator, we have 2 separate fractions. So let's combine those into one fraction to start, because it's very improper to have a fraction within a fraction. So step 1, we're going to combine 1 over a plus h and 1 over a into one fraction. So what's the common denominator? It would be a plus h times a, because they technically don't have anything in common. So we need to multiply the first fraction by a over a, and the second fraction by a plus h over a plus h to create a common denominator. So that would leave us with a over a times a plus h for the first term, and a plus h over a times a plus h for the second term. So again, what I did is I multiplied the first one by a over a, and the second one by a plus h over a plus h to make a common denominator. And the bottom, of course, is still h. Okay. Now that the 2 fractions in the numerator have the same denominator, we can combine them into one, which was the goal all along. So we now have a minus a plus h divided by a, times a plus h, all divided by h still. Okay, so now in this numerator, we have a minus parentheses a plus h. If we distribute through this minus sign, that ends up being a minus a minus a minus h, because this minus sign gets applied to both. Then we have a times a plus h, and finally all still divided by h. Just as a side note, everything we're doing right now is algebra, not calculus. So this is stuff that technically you have seen before, but I know with all the different letters and the large fractions, it can be a little overwhelming. But ultimately, we're trying to simplify this as much as possible. So now a minus a is 0, which means all we have left up top is minus h. So let me rewrite that. Minus h divided by a times a plus h, all divided by h. So we still have an improper fraction since we have a fraction within a fraction, but now instead of having 2 fractions in the numerator, we just have 1. So we're on our way. Let me go to a new slide. So we have the limit as h approaches 0 of negative a over a plus h. Let's see, did I write that down right? Yep. Okay. So now the question becomes, how do we deal with a fraction divided by something else? And the answer for that, thankfully, is quite simple. If you have a fraction divided by something, you simply multiply your 2 denominators. So I'm going to take the denominator from the top and the true denominator of the whole fraction and multiply them together to get rid of my improper fraction. So I still have a limit. We haven't done that part yet. My numerator is still negative h. Sorry, having trouble with the delay again. There we go. Negative h. But now my ultimate denominator is a times a plus h times h. So I'm going to put that h out in the front just to make it obvious. Ha, ha, ha. If you watch this video and you make it this far to the ha part, send me an email and tell me that for a free bonus homework of 100, or AKA a free drop at the end of the semester. Okay, now we have an H at the top, an H in the bottom, which means we can cancel them out. Why is this a good thing? Because that H in the bottom is still making the entire denominator be 0 when we plug in H equals 0. So that's still preventing us from direct substitution. So now what we have is limit as H approaches 0 of -1 up top. That negative is still there, but the H is gone. And in the bottom, we just have A times A plus H. Okay, so now that we've simplified this as much as we possibly can, we have to sort of start over and ask ourselves, can we now direct substitute H equals 0? So if we plug in H equals 0 to this denominator, it no longer creates a denominator of 0, which means we can direct substitute. So we will now drop the limit because we're going to plug in H equals 0. So we have A times A plus 0, which of course is A squared. So final answer is -1 divided by A squared. So remember, what were we even doing? We were trying to find the slope of the tangent line to the function 1 over x at x equals a. Now, since this stayed generic with an a and not an actual number, this means that you could now use this formula, -1 over a squared, for any value of x that I gave you. So if I would have said, find the slope of the tangent line of 1 over x at x equals 9, you would just plug in 9 for a, and that would be your slope. Okay, but this is the final answer, -1 over a squared.